Well, the chain rule is applied when taking derivatives of the composite of two functions. For example, this x squared has been substituted into the sine function. So with the sine function being the outer function, we take the derivative of that first. So we'll have the derivative of sine is cosine, and x squared is left alone. Then the chain rule says, now take the derivative of the x squared and multiply with that. Okay, so there's the derivative. Next, find out where the derivative is equal to 0, or in other words, where the slope of the tangent line is equal to 0. So then we've got one trig function and one algebraic function. We set each one equal to 0. So one of them says, where does cosine of x squared equal 0? The other one, when does 2x equal 0? So of course this one is x equals 0. And then for this one, we've got to find out, well, where does cosine equal 0? So take a look at the graph of cosine, which starts at 1, dips down to -1, and then goes back up with a cycle of 2 pi. So in the middle would be pi. Right here where it crosses the x-axis would be pi over 2, and this would be 3 pi over 2. So far we've got two solutions. X squared is equal to pi over 2, x squared is equal to 3 pi over 2. Now if we followed cosine out another cycle, we could get even more solutions. So we could get two more solutions by going out here, and then we could get two more, and two more, and two more, and two more. This says work with the interval from 0 to pi, and you might think, well, you've already gone past pi, but this part right here, that's just for this which says cosine of something equals 0. So I'm just trying to find out, when does cosine equal 0? We then need to take a look at the original function on that interval and see how many solutions we should keep. So if we graph sine of x squared on the window from 0 to just pi, the biggest sign it gets is 1, so -1 to 1 for y is fine. And now take a look at the graph. So the question is asking for when the slope equals 0 for the tangent line. So that would be a horizontal tangent line, which would happen right here, down here, and up there. And also we found that x equals 0. So if I change the window just slightly, have it go from -1 to pi, you can see that sure enough, x equals 0, there would also be a horizontal tangent line right there. So we need 1, 2, 3, 4 solutions. Okay, so keep the first 4 solutions. Well, here's one of them. And then 2, 3, and 4. So it looks like we need this one. Well, for that one, this length right here is pi over 2. And because these graphs are symmetric, this length has to also be pi over 2. So in other words, this point right here is at 2 pi plus pi over 2. And then if you get a common denominator, that's going to be multiplied by 2 on the top and bottom. So that's going to be 4 pi over 2 plus another one is equal to 5 pi over 2. Now keep in mind, all of that is for what x squared equals. So we're going to have x squared equals pi over 2, and x squared equals 3 pi over 2, and x squared equals 5 pi over 2. So x is equal to the square root of that. And then the last thing I'm going to do is go back to the graph and check that these solutions look right. but I think that should do it. Those three right there, along with 0. So go back to the graph, and of course 0 I know is the origin, so that one's right. Next, how about the square root of pi divided by 2 is hopefully that point right there at the maximum. Good, that one is, you can just see it up there flashing. Next, how about the square root of 3 pi divided by 2? Is that one down there at the bottom? And finally, the square root of 5 pi divided by 2. Is that one up there at the top? So we've got all 4 solutions between 0 and pi.